which you can't return, or at least not in the form in which you went in.
Go where no one has dared to venture. Take a virtual tour of the deadliest places in our galaxy and beyond. It's the ultimate frontier adventure. Space travel. But when trekking through the galactic jungles, one must steer clear of the cosmic hot zones, places teeming with violence and intrigue.
There are dangerous places, certainly very energetic phenomena that are a lot more powerful than atomic bombs being detonated, infinitely more powerful.
The universe does seem to be a very violent place. It seems to have been born in a violent explosion called the Big Bang, and there's all sorts of violent processes going on.
On December 27th, 2004, satellites picked up the greatest cosmic explosion ever recorded. A blast 30,000 light years away, which had the power to briefly alter our planet's upper atmosphere. The blast was caused by a magnetar, the densest and one of the most dangerous stars in space.
The magnetic field strength of a magnetar is about 1,000 trillion times the magnetic field energy of the Earth. And for reference, this would wipe the information off a credit card at a distance of about 100,000 miles away. Now this distance is sort of half the distance to the moon, so it's very nearby by astronomical standards.
These mischievous stars have the strongest magnetic field in the universe. Scientists have confirmed 12 of these rare stars in our galaxy, and there may be more. Caltech's Brian Cameron scans the Milky Way for these strange stars.
Magnetars are a special class of neutron stars with ultra-strong magnetic fields, the densest form of matter in the universe. The first magnetar showed itself in the form of a high-energy event that was detected in the late 70s, although at the time we didn't know that it was a magnetar. It wasn't until the early 90s that researchers suggested that these objects were dominated by magnetic fields, and that the magnetar theory was actually confirmed.
Magnetars are born out of the death throes of massive stars. When a star dies, it begins to collapse and go supernova. Sometimes a dense neutron star forms from the cinders of that supernova explosion. During the process, a few neutron stars become magnetars, which possess a strong magnetic field. These stars eject high-energy emissions of X-rays and gamma rays.
We think that normal neutron stars are born from regular stars that are something like 10 or 20 times the mass of the sun. But there's evidence that magnetars are born from possibly even more massive stars than this, something like 40 times the mass of the sun.
Typically, a star of such mass would be too heavy to form a neutron star. Instead, its mass would collapse into a black hole.
Black holes are formed from cramming a certain amount of mass in a certain volume, and for whatever reason, these stars are unable to do that.
One theory is that some massive stars undergo a weight loss program right before exploding as a supernova, losing 90% of their mass. So instead of collapsing into a black hole, the emaciated star becomes a neutron star with extreme magnetic powers. When the magnetic force gets incredibly strong, it deforms the magnetar's crust, creating seismic events called starquakes on its surface.
Now eventually this crust breaks under the stress, and the magnetic field reconfigures itself into a lower energy state. And when this happens, a fireball is launched off the side of the star. So starquakes on neutron star surfaces are thought to give rise to these giant flares that we see. After a magnetar undergoes one of these flares, it outshines all the stars in the galaxy for the few tenths of a second that it's taking place.
Within these giant flares are short bursts of gamma rays which move at the speed of light.
The giant flares from magnetars are gamma ray bursts. They're very short in duration, less than a second, and have very hard X-ray spectra compared to another class of gamma ray bursts.
If a deep space traveler veered off course and was unlucky enough to pass within 700 miles of one of these massive objects, the consequences would be horrific. The magnetic field of the magnetar can literally warp the atoms in human flesh, and its gravitational forces would tear a person apart. So then, how close would a magnetar have to be to wreak havoc in our solar system? Some suggest that a blast from a magnetar even 10 light-years away could produce cosmic chaos that would destroy our ozone layer and cause mass extinctions.
The chances of that happening are so low that, they're completely implausible. It would be no different than a regular star passing through the solar system. And we know that the regular star has not passed through the solar system since the solar system formed.
Scientists think that magnetars are only a few thousand years old and will become dim after 10,000 years.
We're just now starting to understand the life cycle of magnetars. We think that they're very young, but how young is still uncertain.
In addition to magnetars, satellites and ground-based observatories have been picking up other violent things in space. Scientists have now confirmed the existence of a phantom-like force that's so strong that it might very well be the most vicious phenomenon in the universe. Stealthy villains haunt each and every galaxy. One particular beast tears up anything in its path and gobbles it down like a cocktail hors d'oeuvre. It's one of the most bizarre and destructive phenomenon in the universe, a black hole.
I think a black hole is the place which is more violent than anywhere else in our universe.
It's like going over the edge and you can't get back. It's fatal attraction, I suppose.
A black hole is a region of space where the pull of gravity is so immense that nothing can escape it, not even light. Astrophysicist and triathlete Ferry Alozel is attempting to unlock the mysteries surrounding this elusive cosmic force.
In a black hole, the gravity is so strong that no other force can compete with it, so everything collapses to a single point.
Ozel says whatever has a close encounter with a black hole will fall victim to its relentless tidal force of gravity.
Imagine you're swimming in a pool and there is no current. You can go whichever direction you want. Now imagine you're taken out of the pool and you're in a river. Imagine a current that is much, much, much stronger. that the only direction that you could go would be with this current. The space around the black hole acts like this wild river. You could never fight this enormous drag that you feel.
As an object approaches the edge of the black hole, called the event horizon, it reaches the point of no return.
As you come closer and closer to this event horizon, you would already be approaching this extremely fast motion of space under you. And your only future direction is now into the black hole.
The idea of the black hole as a whole sometimes can be a little bit confusing. What it really is, in some sense, it's a place from which you can't return, or at least not in the form in which you went in.
Black holes are difficult to detect because, as the name suggests, you cannot see one by itself because it's black. But scientists have spotted a black hole when its gravity affects something else in space, such as a passing star.
A completely isolated black hole would not be visible. What we really see from a black hole is actually the hot material that's swirling around it and that's being sucked into it.
So in the neighborhood of these powerful black holes, you'll get a lot of radiation resulting from the black hole pulling in material and stretching it and twisting it as it's falling in.
Black holes consume anything in close range, and there are billions upon billions of them prowling the universe. Astrophysicist Andrea Ghez is one of the world's leading black hole hunters.
Black holes are not picky eaters. They'll dine on whatever get nearby. So they will happily eat gas. They will happily consume a star or a planet. When a black hole dines in a star, it does so first by tearing it apart. You might think of silly putty being stretched out and then it just streams on in, sort of like water going down a drain. It's completely pulverized.
Black holes are produced, we believe, by the collapse of the core of a massive star, something like 25 or 30 times the mass of the sun or more. When it comes to the end of its lifetime, a massive star burns its core all the way past helium, carbon, nitrogen, oxygen, all the way to iron, which has no more nuclear fuel. And when that iron core builds up to a certain mass, there comes a point where it can no longer support itself, and the core will collapse all the way to a black hole, producing at the same time a supernova.
The supernova sends out explosive amounts of energy, so anything in its vicinity will get obliterated. Then the remnants of the explosion fall into a newly formed black hole. And it seems the key to the black hole's allure is gravity.
Gravity will pull things around, just like the sun's gravity pulls the planets around. In fact, stars will happily orbit the black hole for most of its life and won't actually be sucked in. These stars are actually safe from the fatal attraction of the black hole. But if you do venture too close, like extremely close to the edge, then you do get sucked in.
Scientists believe there are millions of wayward black holes throughout our galaxy, the Milky Way. And because we can't readily see them, one could be right next door. So how close does something have to be to get sucked into a black hole?
Too close to a black hole is about the distance between the sun and the Earth, but that is certainly too close.
For future space travelers, death by a black hole would be a violent way to go. The method by which a black hole could kill you depends on how big the black hole is. They come in two categories. Most of them are the stellar mass black holes. which are 5 to 30 times the mass of our sun.
If the black hole is stellar-sized, then the tidal forces near the black hole are strong enough that it will tear you apart tidally, even well outside the event horizon. If you wanted to fall into a black hole, you certainly wouldn't want to fall into one of those. It will spaghettify you.
But in addition to the stellar-sized black holes, there are others that are mammoth, millions to a billion times the mass of the sun. And now scientists believe that these monsters hold center court in every galaxy, including our own. Black holes. They're one of the most mysterious and potentially dangerous oddities in space. A black hole has a ravenous appetite. It sucks in everything in its path and spits out what it doesn't devour. And now scientists have discovered there are supermassive black holes, which are millions of times bigger than their stellar mass cousins. And evidence suggests that supermassive black holes were born after the Big Bang, when the universe was first created.
The leading idea is that they would have formed just like a stellar black hole from the collapse of the core of a massive star. But then they grew by feeding grossly from the gas, from other galaxies which collided with them.
Scientists have discovered that these black ogres wield their power in the center of galaxies.
The supermassive black holes are at the center of the galaxy, most likely because they're the most massive object within the galaxy. Massive objects tend to sink to the middle, so you'll always find them at the center of a galaxy.
For a long time, scientists didn't think a supermassive black hole existed in our neck of the universe, the Milky Way. But in 1995, astrophysicist Andrea Ghez set out to prove one exists.
We've done an experiment over the last 10 years to ask the question, is there a supermassive black hole at the center of our galaxy? And the way we did this experiment is to use the motions of stars at the center of our galaxy to test whether or not there's a large amount of mass inside a very small volume. And that's the proof of a black hole.
At the Keck Observatory in Hawaii, which houses one of the largest telescopes in the world, Ghez began using a groundbreaking technology called adaptive optics, which brings into focus faraway objects.
So this is without adaptive optics. This is what you would see. In this big square, there's nothing. We turn adaptive optics on, and you see the stars. This region contains the stars that provide the keys to our experiment. So we want to watch how these stars move.
Ghez noticed that there was a large cluster of stars orbiting around an invisible object at the center of our galaxy. And they were moving at an unusually rapid rate.
So we can actually see these stars that are really close to the center, and we can watch them go around. Those stars go around the black hole just the way the planets orbit the sun. The orbits tell us where the black hole is, so it's located right where the star is. That's the center of our galaxy. And the details of exactly how fast these stars are going around and how tight the orbits are tells us the mass of the black hole, which we think today is 4 million times the mass of our sun.
For Ghez, confirming that a supermassive black hole indeed exists at the heart of our galaxy was like summiting Mount Everest.
It was incredibly exciting to discover the supermassive black hole at the center of our galaxy, simply because it was a question we had set out to address. The question, is there a supermassive black hole? And we could design an experiment that actually got at it.
Astrophysicist Andrew Hamilton says death by a supermassive black hole would be much different than by its smaller stellar mass relative.
If you want to go and be a tourist and have the ultimate experience of falling inside a black hole and finding out what's really there, go visit a supermassive black hole. A much better idea.
Unlike a stellar black hole, which would rip you to shreds before entering its deadly vortex, a space explorer could actually experience free-falling inside a supermassive black hole.
Inside a supermassive black hole, it turns out that even though the black hole is more massive, it's also much larger in size, and that means that the tidal forces are weak enough that you could pass through the event horizon and fall deep inside the black hole without being tidally torn apart. But deep down inside the black hole, the centrifugal force of the rotation of the black hole provides effectively a repulsion. If there's any matter at all inside it, then stuff that's falling in will tend to collide with stuff that's trying to get out. And the result of that collision of energies is an unimaginably chaotic maelstrom of super hot, dense plasma. And in that case, your fate is that it can roast you.
So how close would space travelers have to be to get sucked into a supermassive black hole in the center of a galaxy?
For a supermassive black hole, you would have to be about 1 million to 1 billion miles from the black hole to feel its influence.
Over the years, the Chandra X-ray Observatory has caught our galaxy's supermassive black hole nibbling on cosmic matter, not binging like other supermassive black holes.
Our black hole is today inactive compared to other black holes. Our galaxy has very little gas at the center, and so there's nothing really for the black hole to feed on.
It's not eating very much. It's going on a bit of a starvation diet.
Our galaxy's supermassive black hole appears to be fasting. This is partly due to the fact that as a galaxy ages, less and less matter is present for it to gorge on.
But in the future, it might be quite a bit more active if it ever gets a fresh supply of gas at its center to feed off of.
One way to rejuvenate our supermassive black hole's appetite is to collide with another galaxy. Sound implausible? 2 million light years away, our closest neighbor, the Andromeda Galaxy, is charging toward us at almost 75 miles per second, or 270,000 miles per hour. In the future, scientists predict the two galaxies will collide. And upon impact, the larger galaxy may engage in one of the most primitive acts known in the universe. It's one of the most barbaric rituals in space. A larger galaxy eats a smaller one. The scenario isn't a science fiction writer's fantasy. It's a cosmic reality. It's called galactic cannibalism. The ghastly event can occur on the celestial highway when two galaxies have a head-on collision. Both eventually meld together in a less than harmonious merger.
If you're a galaxy, it's very violent. You're torn to shreds.
Joshua Barnes studies galaxy mergers. Acting like a crime scene investigator, he admits his research is a bit like inspecting a car crash.
Imagine that you come across the scene of a car crash. Two wrecked vehicles, but no witnesses. Nobody to tell you what happened. All you have is the physical evidence. That's basically what we have to do when we study colliding galaxies. So there are no witnesses to a galactic collision. All that you have is the present state of the wreckage. So you have to conduct a sort of forensic investigation to try and figure out what happened on the basis of what you have today. If they collided head-on, you would know because the fronts were squashed up, but if they, say, sideswiped each other, which is actually more likely, galactic collisions, that would leave you a completely different pattern of wreckage, and you could interpret that.
So what causes galaxy mergers?
It's gravity. Everything in the universe is falling freely through space. And where you've got two large objects like galaxies, their mutual gravity pulls them together so they fall into each other. So it's really just the force of gravity pulling things around. The galaxies that we're seeing colliding today, most of them have been bound and destined to collide for upwards of 10, 15 billion years, and they're only now just making it to that first collision.
Our own galaxy, the Milky Way, is moving toward our neighbor, Andromeda. Both galaxies are spiral in shape, but Andromeda is about twice as massive, with a supermassive black hole the mass of 30 million suns.
It'll look a lot like a dance. And you see the two galaxies come close together, so they kind of dance around each other, getting closer and closer and moving faster and faster before they finally come together.
But at the point of impact, these galactic dancers will do more than pirouette.
Each one has a spiral disk of stars, and then surrounding that, a halo of dark matter, invisible material that we can detect by its gravitational field. These two dark halos, which are much larger, will overlap as the galaxies pass by. Eventually, as the two galaxies spiral around each other closer and closer, you can no longer distinguish them as separate systems, and finally the nuclei merge.
When Andromeda and the Milky Way collide, that's going to be the biggest collision that the Milky Way has seen, something like 5 billion years' time. The good news is that we, the solar system, will have a grandstand view. What will happen is the two galaxies, their spiral disks, are going to get tidally torn apart into fantastical shapes.
When the disks start to get close to each other, they'll throw off long streamers of stars, so-called tidal tails. And what happens to the sun and the solar system, should we still be around, it really is hard to predict. We could get lucky and be on one of those tidal tails and get a sort of bird's eye view of the whole process as we fly out. Or we could get thrown into an orbit plunging towards the center of the merging galaxies. There's basically no way to say.
During the merger, if our solar system moves through the suburbs or the edges of Andromeda, we might not notice anything. On the other hand, countless stars and space material could be propelled towards the planets, potentially disrupting their orbits around the sun. Moreover, the entire galaxy could face cosmic upheaval.
We could have consequences which would nonetheless be dangerous. First of all, we could have a lot of star formation as a consequence of the merger. Currently, both the Milky Way and Andromeda galaxy have plenty of interstellar gas, the raw material from which stars are born. Now that would mean a lot more evolved stars, supernovae, going off in our vicinity. And that could create shock waves, blast waves, bursts of cosmic rays, which would have nasty consequences.
After the merger, the fate of our solar system is uncertain, as the supermassive black holes of Andromeda and the Milky Way vie for power in the newly jumbled galaxy.
When they merge, they're going to form a new galaxy, and these two supermassive black holes will gradually spiral into the middle of the new galaxy. They will be a binary black hole for a short time.
And these black holes will start to swallow gas as the collision stirs things up. Gas will fall into those black holes. They're going to turn on. They're going to start emitting radiation. But the potential for fireworks, possibly for fueling the black holes at the centers of the galaxies, matter falling into them, possibilities like that do exist. And then the only safe place to watch the process would be on one of those tidal tails riding out and escaping the collision.
Some scientists think that Andromeda's larger supermassive black hole will eventually consume the Milky Ways.
the two black holes will spiral in the center and become a binary black hole, and ultimately will merge with one another to become yet an even bigger supermassive black hole.
So a small galaxy colliding with a large galaxy is likely to be dominated by the larger galaxy. It'll essentially have most of its material absorbed by that galaxy and become subsumed into it.
Scientists believe galaxy mergers are a way of life in the universe. Modern galaxies, including the Milky Way, have grown larger by cannibalizing smaller galaxies.
Every galaxy that we see has probably been through many collisions. The Milky Way has a central bulge of stars, which are probably the relic of a previous collision.
Most scientists agree that the much-anticipated merger between the Milky Way and Andromeda won't happen for at least 3 billion years. But there may be more immediate dangers in space. In cosmic neighborhoods millions of light years away, there are hyperactive galaxies that have become the big bullies on the block. At the heart of some galaxies lives a cosmic monster. It transforms a run-of-the-mill galaxy into one of the brightest and deadliest in space. Quasars are peculiar objects, each powered by a supermassive black hole that continually swallows large amounts of matter, 10 to 20 stars every year.
At the core of these objects lives a very large black hole. And the role of that black hole is to actually generate a huge amount of energy.
Quasars are the most energy-efficient mechanisms in the cosmos. They give off more power than 100 normal galaxies. And they're 10 trillion times brighter than our sun. So how are quasars created in the universe?
There's a fairly good connection between the last stages of a galactic merger and the so-called quasar phenomenon. If that really happens in the case of the Milky Way and Andromeda, we could have, for a period of some tens or possibly even 100 million years, a quasar active in the center of the merged galaxies. And a quasar puts out about 100 times as much energy as a typical galaxy. And if we were actually thrown into an orbit which took us towards the center of the galaxy, we could get very close to that quasar and really get scorched.
The word quasar stands for quasi-stellar radio source, which means star-like emitters of radio waves. The word was coined when the quasar phenomena was still a mystery. Now we know they're not star-like at all. In addition to emitting radio waves and visible light, quasars also give off ultraviolet rays, infrared waves, X-rays, and gamma rays. All deadly if something or someone gets too close.
A quasar is a supermassive black hole at large distance that is active. It's powerful, it's emitting light, and we can observe it in many wave bands.
Quasars were first discovered in the 1960s, but as radio telescope imaging got better, astronomers discovered that some of those quasars also have powerful jets beaming out of them. These particular quasars are called blazars, probably some of the most violent phenomena in the universe.
Blazars are powered by black holes, just like quasars, but they're somewhat different in that all of that energy is being focused, or a large amount of that energy is being focused into jets, which are streaming out.
A blazar's aggressive plasma jets produce radiation in the form of radio waves all the way through the spectrum up to high-energy gamma rays. Astrophysicist Glenn Piner has been investigating the physical conditions at the centers of these exotic galaxies.
We can use this fountain to visualize the geometry of a blazar. If that circular base of the fountain represents the accretion disk, then the jet of water that's coming up represents the jet of plasma coming out from the blazar. And if the Earth is sitting up in the direction that that water is going, then we would see this object as a blazar.
To an astronomer, it's like looking down a fire hose. It really gets you in the eye. You see this bright, blazing thing that we call a blazar.
These blazar jets move exceptionally fast. The fastest observed move at 99.9% the speed of light.
If you were to take a small object like this bowling ball and you wanted to accelerate it up to 99.9% of the speed of light, you would have to give this bowling ball all the energy produced in the world for an entire week to accelerate it to that speed. And in these blazars, we're accelerating not just small objects like bowling balls, but large masses of the mass of the planet Jupiter, or larger, to those speeds. So they're being given incredible amounts of energy by this efficient engine.
Blazars pose unimaginable consequences to cosmic objects that get too close to its deadly jet.
If there was a planet relatively close, a few light years from the actual jet, the radiation on that planet could be millions of times what it gets from the star. It would be continually exposed to high levels of radiation. So I don't think we want to look for life on a planet that would be orbiting a star that's in a blazar jet.
It's a place from which you can't return, or at least not in the form in which you went in.
Go where no one has dared to venture. Take a virtual tour of the deadliest places in our galaxy and beyond. It's the ultimate frontier adventure. Space travel. But when trekking through the galactic jungles, one must steer clear of the cosmic hot zones, places teeming with violence and intrigue.
There are dangerous places, certainly very energetic phenomena that are a lot more powerful than atomic bombs being detonated, infinitely more powerful.
The universe does seem to be a very violent place. It seems to have been born in a violent explosion called the Big Bang, and there's all sorts of violent processes going on.
On December 27th, 2004, satellites picked up the greatest cosmic explosion ever recorded. A blast 30,000 light years away, which had the power to briefly alter our planet's upper atmosphere. The blast was caused by a magnetar, the densest and one of the most dangerous stars in space.
The magnetic field strength of a magnetar is about 1,000 trillion times the magnetic field energy of the Earth. And for reference, this would wipe the information off a credit card at a distance of about 100,000 miles away. Now this distance is sort of half the distance to the moon, so it's very nearby by astronomical standards.
These mischievous stars have the strongest magnetic field in the universe. Scientists have confirmed 12 of these rare stars in our galaxy, and there may be more. Caltech's Brian Cameron scans the Milky Way for these strange stars.
Magnetars are a special class of neutron stars with ultra-strong magnetic fields, the densest form of matter in the universe. The first magnetar showed itself in the form of a high-energy event that was detected in the late 70s, although at the time we didn't know that it was a magnetar. It wasn't until the early 90s that researchers suggested that these objects were dominated by magnetic fields, and that the magnetar theory was actually confirmed.
Magnetars are born out of the death throes of massive stars. When a star dies, it begins to collapse and go supernova. Sometimes a dense neutron star forms from the cinders of that supernova explosion. During the process, a few neutron stars become magnetars, which possess a strong magnetic field. These stars eject high-energy emissions of X-rays and gamma rays.
We think that normal neutron stars are born from regular stars that are something like 10 or 20 times the mass of the sun. But there's evidence that magnetars are born from possibly even more massive stars than this, something like 40 times the mass of the sun.
Typically, a star of such mass would be too heavy to form a neutron star. Instead, its mass would collapse into a black hole.
Black holes are formed from cramming a certain amount of mass in a certain volume, and for whatever reason, these stars are unable to do that.
One theory is that some massive stars undergo a weight loss program right before exploding as a supernova, losing 90% of their mass. So instead of collapsing into a black hole, the emaciated star becomes a neutron star with extreme magnetic powers. When the magnetic force gets incredibly strong, it deforms the magnetar's crust, creating seismic events called starquakes on its surface.
And eventually, this crust breaks under the stress, and the magnetic field reconfigures itself into a lower energy state. And when this happens, a fireball is launched off the side of the star. So starquakes on neutron star surfaces are thought to give rise to these giant flares that we see. After a magnetar